of a PDS network, and it doesn't continue from there to the desktop. It's left to the user, to the local accrediting authority, to configure exactly how it interfaces. And as you're going to see, this is one of the big sources of problems that we see going forward. Now, the problem that really evolves is that SCIFs, PDS areas only protect space. They don't protect equipment. And that's what we're going to focus on today. It also, because there is no policy, it's left to local interpretation. So now you get whatever the local security officer or the local command or the local information assurance management team states is what they actually will approve. So it can vary all across the waterfront. There is no real consistency because there is no policy that covers this last 6 feet to the desktop. Because of that, we give you people like Edward Snowden and Bradley Manning, because they were authorized in authorized areas, they were authorized people, but because the equipment itself wasn't secured, once they were within a SCIF, they had access basically to the cloud. And you can readily recognize the damage that was done as a result. The other point is that as we look at layering security, layering cyber and physical security together, we're looking at not only the insider threat, but we have to also be cognizant of the outsider threat and human error, which is one of the biggest problems when you integrate physical security solutions at the endpoint. It has to be, they have to be aware of what they are, they have to be disciplined, and they have to work with the rules of the road that they have to engage in. Now, first of all, there's a big cultural difference between physical security and IT. Culturally, I kind of label, we have C4I in the IT world. I have the equivalent in physical security that I've had to live with for 35 years. It's what I call G3D, and that stands for guns, gates, guards, and dogs. And so that's where we end up with a divergence of cultures. The point being that one is very dynamic and physical security is very static. That you have the IT world being technology driven and physical security is facility driven. It's based on the building that you're in, which also makes it, you work at the speed of light with technology and you work at the speed of a glacier with physical security. And you're also in a world where technology, and particularly in the cyber world, dominates the funding, the thinking, the manpower, and physical security is kind of left as an afterthought. The other aspect of it is that physical security is always tangible. You want something where you can kick the tires. Whereas in the virtual world, which is getting more virtual with virtual desktops, software-defined networks, it's getting more virtual as we go along. So the mix between software-operated networks and the hardware tangibility of the network itself becomes a real dichotomy that is hard. It's a hard bridge to gap. One, of course, technology is online, and they usually look at physical security as an offline storage or an offline security protocol that is not tied to a network but to a facility. And so therefore, the IT people want everybody to see everything all the time, and the physical security guys don't want anybody to see anything ever. I'm reminded of what we've been doing for 35 years is trying to bridge that gap ever since I'd started out as a VAR with Sun Microsystems back in 1984, 85 when they first started. So there, the whole culture was the network is the computer. And with that mindset, it became a very challenging effort. Little did I realize it would take me 30-some years to be an overnight success. But in any way, the one guideline that I've always had comes from Yogi Berra, of all people, who is famous for his philosophical one-liners. The one I like to use is, when you come to a fork in the road, like IT security and physical security, take it. And that's what we're doing. And we have been for some time. And I think as we go through this, you'll see that there has been some progress made, but the threats and the technology expand it and make it very difficult. Now, cyber security works through the network. Physical works around it. We also have where cyber is reactive. And because it's reactive, it's waiting for the next threat to happen. The phrase I came up with, it's like playing cyber chess. You're always trying to anticipate the next 2 or 3 moves, but you don't know what happens until they're actually played. Whereas with physical security, it is proactive. It is on the outside looking in, and it is something that can actually allow control of the user interface, control of the access to the network, as well as relying complementary on the fact that they have to work together in unison in order to protect the network as it should be protected. Now, the other aspect of this, I mentioned insider threats and outsider threats, is the human factor. Security is fundamentally a people problem. And it's either people who are deploying the network, securing the network, operating the network, or having to manage the network in a program management function. And when you usually have a breakdown in security, many times it's people causing it, because that endpoint interface then becomes vulnerable, and it also requires some form of proactive access control. It's one thing to have your SIPR token and be able to log on and go through the Active Directory and be able to get online and offline, but you have the hardware sitting there. You have switches, you have crypto devices, you have SIPR laptops, you have the desktop, keyboard, monitor, and mice. And it's usually under the user control of having to pull hard drives out of safes and having to go through a fairly complex process in order to enable the user to get online and offline. And over time, the inclination is to cut corners. So the discipline, the consistency can waver. This then is to go after the threat. What we want to talk about today is going at it from the outside in, and how can we mitigate some of these problems. Now, small little background here. There was a huge sea change that took place in around 1990. And that was, the threats changed quite a bit because the wall came down. It was not a bipolar threat. It became an asymmetric threat. And that at that point, the SCIF, the physically secured space, usually had everything encompassed in that space. Nothing got outside of it. But what happened then is digital communications started to play a big role. And what happened after that is that the network started to distribute out, and the database was not contained within one SCIF or one facility. It was distributed pretty much around the world. So what happened is, of course, the internet was the enabler here. And it changed everything in terms of how data was handled, how it was distributed, who had access to it, where were the access points, where was the data stored and secured. And because of that, it then enabled a multitude of other things to happen. It became an asymmetric threat from all different kinds of people, all different countries, rogue countries, nation states, and all others. And then, of course, it became a big playground for hackers. And so now you could use the intelligence of the computer against itself. And that became a big problem. From that point, it turned out that when we looked at that sea change that took place around 1990, the real problem was physical security didn't change at all. So it was left the same. You still had a SCIF to deal with, you still had PDS to deal with, and even though it started becoming this huge worldwide monster, the physical security folks were still adhering to traditional policy that no longer met the challenge. And what also happened at that point is that SCIFs changed. They weren't an all-encompassing controlled environment anymore, but they became a network portal. So now when you were in a SCIF, you just didn't have access to the data that was in that SCIF. Like Edward Snowden, you had a portal to Fort Meade. Like Bradley Manning, you had a portal to the State Department archives. And that's where the vulnerability and the threat has really come into play. Also, the way you looked at the desktop and the user interface, that fundamentally stayed the same. Keyboard, monitor, mouse may have gone to flat panel displays and they got faster and you got more bandwidth, you got more response. But the fundamental user interface between the man and machine remained the same. So technology was outstripping this until what came along around 1990 at that time was a set of physical security devices called IPS containers. GSA came up with the name. Everybody tells me it's intrusion protection system. It is that too, but it's basically GSA came up with the name Information Processing System Security Container. A mouthful, so we call it IPS container for short. And we're going to talk about, as a case study, how the IPS container can be used as a means of providing network physical security at the endpoint. And this is what one looks like. Basically, it's a fairly simple device. It's a storage container that's been modified to make it an armored computer cabinet. So it has internal cooling, internal rack mounting, and internal secure way of getting cables, both power and data, in and out, so that you have what we affectionately call a SCIF in a box. And this has been one of the areas, in fact, the only area in physical security that is actually was technology-driven and threat-driven, not just policy-driven. Now, some lessons learned over the last number of years. We started working with CyberNet back in the 90s when it was first stood up in Europe, and we learned a number of lessons. And these are the things that are important. First of all, you got to address all threats. Secondly, you need to secure the equipment, not the space. Thirdly, you need to have it seamless from the cloud to the desktop. It can't have gaps. Current policies are stovepipe just like agencies are in terms of how security is applied and where the rules are. You have SCIF policy, you've got PDS policy, you have SAFE policy. And they don't match up. They're all separate. You also want to be tied to the network. You don't want to be tied to the facility, because with bracking and with the changes and expansions and consolidations, you have to be agile enough. I know it's hard to say a safe is agile, but it's at least transportable to the point where it's not tied to a facility where you have to rebuild a SCIF, relay out PDS that is totally unchangeable. So there's a cost factors as well as time and construction that becomes a factor there. And the key is to emphasize online operation instead of offline storage, which is an area that's fraught with error and with the potential for complications. Key is to bring the network to you because the data is now in your hands in real time instead of making you go to the network. And the other aspect is that you have to look at this from multiple perspectives, that you have to look at the IA security protocol, physical security, facility protocol. You've got to look at the user and the user interface. You have to look at program and network management. And you have to satisfy them all. Now, a couple of things and guidelines that we had approached along the way when we looked at trying to solve physical security at the endpoint. One is you want to make sure that you have simplicity. The simpler you make things, the more inclined people are to follow procedure. The more simpler, in fact, the ad that always comes to mind is you want to make it so simple even a caveman can do it, right, as Geico would say. But the point being that the simplicity is what will enable the security. But you have to balance both security and convenience. And that's the real trick as we go forward. Now, the other thing is that everybody's desktop is different. So they have to be functionally different from the standpoint of looking at how it's deployed, how many users, how many users, how many pieces of equipment, how many networks and domains are you dealing with. That all has to be taken into account. And even within a building, you have single user offices, you have small clusters of users, or you have bullpens. You have to address them all. The idea of having it self-contained and modular means you can move it. You can modify it, you can change the equipment in it, and you can alter it so it is actually a non-obsolescent solution. The inherent built-in reliability, if it's going to be running online for a long period of time, you want to keep it running consistently and reliably. It has been proven unequivocally that if you're powering your equipment on and off every day, its reliability can be reduced by up to 80% compared to leaving equipment on and letting it run for a couple of years or for an extended period of time. And that has to do with the power spikes that are associated with it. The next thing has to do with availability. Right now, decisions are being made in the classified world on a real-time basis. That time and place utility becomes critically important to making rapid decisions. With drones flying and with high-resolution satellite data having to get out to the battle space or having to get to commanders or directors who have to make very rapid decisions because you have an opportunity to take out a target or you have to respond to a missile going off. You need that instant, time-oriented, real-time capability, but also it's got to be in the right place at the right time. So it has to be where you need it, not just when you need it. And then the last thing is we all have to deal with budgets and affordability. The last area, the guiding post is how can you make this as cost-effective as possible? Now, the traditional SCIF, and I know a lot of you have seen this, I'm going to gloss over this, but it kind of gives you a point of reference so we're all talking in the same language, is that SCIFs only protect space. The PDS is a permanent labyrinth of connectivity that allows you to convey signals between secured areas. And then the only other thing you're left with is the hardware being stored offline. These countermeasures do not work today in the high-tech world we live in the asymmetric threat world that we have that's ever-changing. And even in the cybersecure space, you're constantly playing catch-up ball. Physical security guys are still back in the 80s, and they're still fighting the Cold War pretty much. And it's a real problem. Now, here's what a traditional SCIF looks like in our little sketched form. But basically, the point I want to make here is that everything is inside the SCIF. It's monitored from inside the SCIF, but the connectivity is all outside. And it takes various forms. You're either having a safe to have to store hard drives or PCs or laptops. You have also the emergence of VTC terminals and voice over IP phones, so you're getting multimedia connectivity at the desktop, voice, data, and audio. And you also have the ability of now having to reconfigure this and change it. So when you look at an IPS container type solution, you're now looking at one that is a self-contained CAA. In fact, DISA has come out with a STIG that does acknowledge that. So it is a CAA unto itself. So it's modular and it's self-contained. It is designed to run in a continuous closed door environment so that you can stay online all the time. And that has huge benefits, not only in reliability, but in connectivity. Because now you can eliminate things like Sipper Tuesday, where you have to reboot your laptops every week just to get the latest antiviral updates. Now, you have it up and running all the time. And if you can work it with the equipment inside the safe, and you can have an access control user interface that can eliminate going into the safe altogether, you now have a very workable solution. You also have to adapt to the legacy networks that are still out there. And so you have to kind of take baby steps to incrementally grow and adapt to the investments that have already been made, but allow them to transcend using newer and more viable technologies. There is a means now where these safes are being put into furniture and put into higher level offices or being concealed, because a lot of times you don't want to have the capability, or you don't want to have anybody knowing that you have classified running in either a conference room or an office or a residence. And so there is a way of concealing this, call it office camo if you want, but there's a way of concealing that presence. But the value of it is that you have the ability of consolidating all your comms into one area, all the red signals are in one safe, all the user interface is on one desktop, and you have a safe, a workstation, and a desk in one module. There are a lot of advantages to that. We also, as we start working up the ladder and have been trying to get into the JWICS world, that requires Tempest. And it's been a real challenge. We're not there yet. But it is something where we're trying to get either a T-SCIF accreditation from DIA or trying to get a means of allowing at least a single user JWICS interface using this type of technology. From that, the way it works is the safe really needs to have two access control functions added to it that are external. Well, one is integral to it, but the other one's external. One is to affect the user interface at the desktop between the IPS container and the desk. And the second one is to control the network equipment and the safe itself, and to be able to do that remotely. You put these together and they make a very powerful tool where the IPS container by itself doesn't solve the whole problem. It can have various sizes and shapes that can be adapted to each particular user requirement. And There are a couple things. One of the legacy things that's been done is they've taken these safes and they've actually adapted a drop box on it, which allows you to have the safe, the switch, and electronics running inside on a continuous basis. You turn it on and off remotely, and you have the ability of then externally in an existing PDS environment attaching your desktops or your user interface. This was one of the first steps that was taken in adapting to the legacy world. Here is an example. This happens to be down at Fort Hood, where the generals have a complete office. And now they have everything consolidated in one area, and you can now have a complete office suite as an operating environment secured. Here's what an example of a tempested safe would look like. The idea here is that you're having layered security in depth that can either add tempest, add physical security, add access controls, and you can combine them all together. Now, between an IPS container and a SCIF, big differences are this. One is fixed, one is self-contained. One protects the space, one protects equipment. It doesn't worry about the safe. It's got the same X10 GSA-approved lock that you have on your SCIF. One is much more cost-effective because you can tailor the security to the site you're at instead of making you adapt to the facility, which gets very expensive, very time-consuming. Construction costs are heavy, and it's immovable. You can't change it. At least with a safe, it's transportable. The lengthy build cycles, if you're building out a facility, if you've done that, you know how long it can take, sometimes up to a year. But with a self-contained container that is adaptable, you can change equipment, you can update it, it's impervious to whatever equipment is secured inside. You can change the architecture of the network with it. You also aren't attached to the facility. You're basically attached to the network. And the fact that it's manpower intensive when you have a facility. You're dependent on guards, you're dependent on dispatchers for security, you're dependent on people monitoring activity inside because they're not controlled once they're inside of a SCIF. Whereas if you can control the user interface to the safe itself, you have complete control of access not only to the network equipment, so you can't plug in USB ports, but you have control of access to the network itself, which is the real key. You want the user to have access to the network, but not that equipment. Therefore, with the user outside, he can now provide a controlled environment where you have access control to the network, not access to the network equipment, whereas with a SCIF, of course, you're inside. Now, a couple things that are important when you want to apply local desktop access control. It would be a mechanism where you layer access control in addition to your normal network application layer logon. As an example, with a SIPRnet node. You have your SIPR token, you have your login. Here, if you can add in two more layers of security, another token and another PIN, you can now control the local desktop, the keyboard, monitor, and mouse. The equipment stays on and running all the time. The desktop is what you turn on and off. And so now you end up with four-factor authentication that gives you security in depth. Because they're online and running, as I mentioned before, no more SIPR Tuesdays, which is a huge operational fault that has been foisted on the user community because everybody's got to open up their laptops, reboot, get up to date. Otherwise, they've got to wait an inordinate amount of time. And the more you're overseas or in remote areas, the longer that wait time can be. This eliminates that because the equipment stays on with the network. The encryption device, switch, the keyboard, the laptop, Any other storage devices are on and running 24/7. The other thing is, because it is in the safe, it is air-gapped. There is no way other than the normal network access that anybody can touch that equipment unless they know the combination to the safe. Now, the other thing that's important is you want to do it in a way that does not touch the network itself, because you want to be able to be, as we say, we're around the network, we're not through it. We complement what everybody does in the cyber world. But what the real role here is to have it independent of the network itself. And that way you can apply local control without having to go through JITC, without having to get inordinate CCRI accreditations, but also allowing the flexibility that you need to be able to adapt to any operating environment regardless of what the network connectivity is. In fact, JITC has exempted this as a physical security versus a network security type package. Now, this is what one looks like, and this is a product that has a desktop authenticator, something like this, which has a CAC and a PIN that is locally enrolled within the safe and only turns on the desktop, whether it's with a VTC terminal phone or keyboard, monitor, and mouse. And then there's a controller that resides inside the safe that is not connected to anything in the outside world. It's totally local. That's what this device would look like. Now, this is how it would cable up. So you can run SIPR and NIPR concurrently. You can even have multiple domains, such as Centrix or Relcan or BICES or other networks, and they can be run all out of the same safe. So now you have a great degree of flexibility in having everything controlled within the safe that's online, and then the ability of turning the desktop on and off with access control. So the second aspect of this is you now have to protect the network equipment as well. And now we get to the other side of the insider. As it turns out, Edward Snowden was an administrator, and he had access. So how do you control that? Well, the way to do that is having, again, a parallel remote monitor of the safe, the lock, and the door, because everything is triggered now on the security of the lock and the door being a non-intelligent barrier to securing that equipment inside. And so what you can do is you can allow a remote IP addressable mechanism, which they use in data centers all the time now, where you do it for temperature and power. They can remotely monitor that safe remotely. It's an IP addressable monitor. What can be done is it can have a couple of features added to it that actually monitor the lock and the door of the safe. So if anybody turns a spin dial, if the lock is left unclosed or the lock is left unlocked, even though the door may be closed, that you can remotely through a dispatch center or a guard station detect that on a continuous basis. So you're now not having to worry about guards patrolling or waiting for something to happen and then have to take up to 15 minutes to respond. You can instantly respond with an alert that would go out, which is an industry standard type alert. They call it an SNMP trap, which is a normal access control alarm mechanism. And that you now have the ability of, once you alert both guards and or others, you now have the ability of immediately shutting the equipment down, because if you control the power inside the safe remotely, you can actually, before someone could enter a combination, turn everything off. So they'd have no network access at all once they got in. Now, this is kind of what diagram of how this would work. Again, Simplicity is very important. Remote control is very important. And that while you're waiting for guards to show up, you now have the ability of immediately responding. Because the trouble with an alert or an alarm is you don't know quite what's wrong. It's like the engine warning light on your car. Something's wrong, your engine could be about to blow up, or it could just be an indicator light, or anything in between. What you want is you want an immediate response capability. This is what gives you true intrusion protection. Now, bottom line is you want to secure the equipment, not the room. You want to have it online and running 24/7. You want it tied to the network and not the facility. You want to limit the exposure of the network equipment. And you also want to be able to monitor and control that equipment externally as well. With that, you have the ability of providing seamless endpoint security from the desktop to the cloud. However, the only thing that's lacking right now is policy. These solutions are ahead of the curve. Policy always lags many times years behind, and we're just starting to catch up. As I mentioned earlier, the existing policies are stovepiped, and they don't address the desktop at all, the last 6 feet to the desktop. And what has to happen is that not only with those policies, is that each agency or each MAGCOM or each military branch has their own interpretation of the policy in terms of how they implement it, which leaves the local custodian, the local user, kind of guessing, well, what's going to work and what won't. And so, because of that, you now get a lot of inconsistency, base to base, of how you can deploy a SIPR environment and get a CCRI. It changes from building to building, from base to base, from operating environment, whether it's CONUS or OCONUS, it's all over the map. So it's hard to apply consistent solutions to it. So that leaves things open to interpretation. The one thing, and since we're at DISA's show here, that I think is important is that DISA has stepped up to the plate and they have a STIG that actually controls that user interface to a certain extent. Number one, it does make the use of an IPS container as an accredited CAA acceptable. And number two, it requires that only network administrators and other authorized personnel have access to network equipment. And therefore, the user is supposed to be kept secure from that. And that is one of the STIGs that now requires for a CCRI acceptance to have a solution in place. The solution using the IPS container, using the integrated Dropbox, using things associated with desktop access control, so you eliminate the user from getting into the safe in the first place, are all implementations that are a manifestation of that policy. The only other thing that's been mentioned, which has been very vague, is they talk about tamper-proofing, and that's done in the current PDS spec, which says terminal devices shall be safeguarded to prevent tampering. Now, what does that mean? I don't know. That's up to, again, the individual interpretation of the local DAA. So, a couple of recommendations here. See how we're doing on time. Okay. Number one is a lot of times what we've seen in the field is you have legacy hardware being put in with newer technology. They have old PCs, old pedestal stuff. I go into basically warehouses of existing equipment they try to throw together. You want the latest and most efficient, least power, smallest form factor, because you want to be able to turn these on and run them for a long period of time and not have to worry about failures. And when one fails, they all fail. So the latest PC out there is the G8. Has a lot of advantages in terms of power management, in terms of speed and performance. You want to have the ability of integrating the network together with switches that can, you don't need a 24-port switch if you got 1 or 2 or 5 users. It just generates heat, it takes up space, and it becomes cumbersome. Now, the next thing is that you want to plan it for operating over an extended period of time. Once you put this in, before you always had to manage things on a weekly or daily basis because it was so manpower intensive to control everything. Here you can actually put it in and let it run and not have to worry about any of these other issues. So if you have outdated hardware or mismatched hardware, it just complicates that process and makes you have to provide more preventive maintenance, more support for it. It also has a couple other factors. One has to do with bandwidth. If you've got everything consolidated in a SCIF or a small area, and you're going through one NIPRNet circuit where you're handling 20 or 30 or 40 SIPR users, that one pipe becomes a real bottleneck. And so the more you can distribute the network connectivity, the encryption devices out to the endpoint, the more bandwidth you have available, the more performance. A lot of complaints I hear about how slow SIPRNet can become because of the traffic, that this helps to alleviate that. And then, of course, the most important thing is getting the performance that you need. The other thing that a lot of people don't talk about from a physical point of view is how you manage your power. A lot of times we'll go in and do a site survey and they've got 4 outlets in a room. Now you got to spend money to update all the circuits if you're going to expand. If you tie the power to something like an IPS container and you modularize it, you can then modularize the power management as well. And it makes it much more of a distributed operating environment that is more reliable long term. The other thing is what to do with encryption. Now, CSFC, Commercial Solutions for Classified, has come on the scene as an alternative to Type 1 crypto. I think the jury is still out as to who will accept it and who won't, but it is a much lower cost alternative that can allow distribution of encryption more to the endpoint. A speech I heard last year from Terry Halverson before he retired, he said, what you want to do is you want to push security to the farthest reaches of the network as far as you can and secure as you can. And that's been a mandate for all of DoD. And so this is a type of a solution that integrates cyber and physical security to enable that to happen. There are people now that are saying, well, if we have to secure the switches because of the DISA-STIG, well, we can just leave the encryption device on the desktop and just pull the key in and out every day. Well, that may physically work, but that crypto device is still a controlled device. Someone has to be there attending to it whenever that key is in. And so that creates more manpower issues and more problems than it solves. The other thing is as you push it closer to the endpoint, as I mentioned, you get more efficient, you distribute the bandwidth, you distribute the access points, and you have a better means of controlling this labyrinth of network topology that's just exploding. And this gives you a way of controlling that expansion in a secure way. The fact that something like an IPS container, unlike a SCIF, is non-obsolescent, that you can always change the hardware, you can always upgrade it, you can always modify it, even with the Tempest enclosure that's used in it. That's a broad spectrum control device. you can put COTS and Tempest equipment and have them coexist. So tech refresh and updating becomes much easier. Adaptability to changing network environments, to relocations, are much more flexible when you have the physical security married to the network, not the building. So, if you want integrated network physical security against all threats, insider, outsider, and human error, please consider using things like the IPS container with built-in access controls. And so when used in conjunction with cybersecurity, you now can offer a seamless user to the cloud endpoint security. And that's what I have to say about that. Any questions at all? I have a few minutes here. Yes, ma'am. There's a microphone right up here if you'd like.
Yes. Hello? Okay. So was there a way to monitor, because it said uninhibited access to network administrators? Was there a way to monitor their activity? Do they have to go through another interface so that their like activities are recorded or something? I just was reading that on one of the other slides.
The answer to that is the one monitor is actually the combination lock itself, that only people who are physically authorized, as you would even going into a SCIF, would have access to the contents of that safe. Nobody else would. So, any other questions? Yes.
I like your analogy of the engine light going on in the car. But with so many false positives with our engine lights going on, none of us would ever want our engine just to stop when the light came on. So do you have some other on-off mechanism besides on-off when the engine light goes on for IPS container?
Part of the problem that you have with trying to localize the physical security in a networked environment, which is really a mouthful when you're trying to solve a problem or trying to engineer a solution that is easy to deploy but yet effective, is that the only thing you can control remotely with network equipment is pretty much the power. Otherwise, you're tied to the network and you have to go through the Active Directory, you got to go through JITC, you have to get approved. And that becomes a real issue of now it's a network-wide, the old gig as they used to call it. It's now a global environment type of solution that has to be managed. Whereas what we're trying to do is to localize that security so that even though when a light goes on, now you can take these SNMP trap signals and you can merge it in with a network performance monitoring tool so that it can be used with, say, CA Spectrum, Orion from SolarWinds, and other network performance monitoring package, put it into their dashboard, and you can use the same dispatchers to respond. So the network people are instantly aware of a potential threat immediately. But the turning off of the power is really a backup to also getting the guards out there, because with this same type of mechanism, you can send email or text message or phone calls to guards to immediately alert them to follow up. So within the 10 or 15 minutes that they're allowed to get to a particular site, they can then respond as a backup. This is really the immediate response to stop the bleeding in effect. Thank you. Good question. Anybody else?
How much of the solution that you're displaying here has any sort of positive response or response in general from the commercial world, the defense world? If it's deployed out somewhere, what has the customers been saying about it?
Well, actually, it's had a very positive response. The only holdup has been getting approval and getting acceptance. So the security people that are willing, both IT and physical security that are willing to not really take a chance. In fact, one of the things I say at the end, you always want to be skating to where the puck is going to be, not where it is. So many security people, this is, by the way, the quote that Wayne Gretzky gave when people asked him why he was the greatest hockey player, and that was his answer, and I thought it was pretty apropos. But the way you should describe your security solution is this. The goal is, how well does your security officer sleep at night? It's not what's written in the policy. It's not what may make sense to some people and not others. It's that security guy knows when he feels secure enough and when he doesn't. So this has been very well accepted. It's growing very consistently. The only holdback has been the existing physical security policy and the lack of any DoD policy of getting to the desktop. Some people are just afraid to take a risk and jump out of their comfort zone to make this happen. Does that answer your question, ma'am? Thank you. Anybody else? Well, folks, I'd like to thank you so much for your time and attention. I appreciate it very much. This is an odd part of the security equation that a lot of people don't talk about, and I really appreciate your time and attention today. Thank you much. Enjoy the show.